So first of all, I just want to welcome everyone to the first 2022 SMPTE Hollywood meeting on visual effects and VR, which has been produced by Barry Goch, who is also our panelist. And Barry approached me at the HPA Awards, which was a fabulous event as well, and talked to me about this idea, and it was an instant yes, yes, yes. So thank you, Rafiq Gagouzian, for being our technical director, and thank you, Ramon Breton, for doing the Eventbrite, and everybody at SMPTE headquarters for helping us with everything. And thank you, our panelists, and as important, thank you, attendees. We are thrilled all to have you. And we also welcome one of our newest sponsors, Scale Computing. So I've spoken too much. I'm going to hand it over to Barry Goch. And again, Barry, thank you everyone. And one last note, thank you, Chris Alvarez, for coming in and helping us with the streaming, and the VES for co-sponsoring this with us. And it's streaming on VES as well. We are thrilled to have everybody with us. Barry, it's all yours. Oh, no, one other thing. Questions and answers, please put them on the Q&A. We will answer them after everyone has given their presentation. Okay, Barry, go on.
Thanks, Linda, and welcome to the webinar. Thank you to the panelists, and thank you so much for everybody who's online joining us from literally all around the world. This is a really exciting time in just technological development, just in general, and so much is changing so fast. And I really thought I really wanted to focus in on something that I felt was a bit overlooked, because virtual production is getting a lot of attention nowadays. But there's another important aspect of technology change that's happening in visual effects, which is the introduction of AI and machine learning into visual effects pipelines and processes. So as Linda said, that was the idea behind the event, to put together a group of people that are experts in this arena, and just to explore how it's changing visual effects and how it will change visual effects in the future. So today our program is going to feature presentations from Autodesk, the Foundry, Visual Effects Supervisor Ryan Laney, and Unity. Please, as Linda said, place your questions in the Q&A bubble, and please also on your question, place who you'd like to address the question first of all. And then and that's as far as I wanted to go with introductions. You can read our panelists' bios on the invite, and we have a great group of people together. So if we can go ahead and get started with Will Harris from Autodesk. Will, please take it away.
Thank you, Barry. And hopefully you folks can see me. Hello, everyone. I hope you're having a good day, whether you're warm, cold, or in between. And yeah, I wanted to chart some of the course of machine learning in Flame, talk about what we've done, and explain a little bit about what we could do. I wanted to start my story about 3 years ago, when we were looking at VFX and color grading and how they have been historically separate, but how we wanted to combine them into one creative tool set in Flame. And around about that same time, machine learning started to be apparent as a useful technology. We were very much aware that there's some commonalities: rotoscoping, depth understanding, and then we with one foot in the world of VFX, we're aware of some of the higher functions, if you like, of rendering, things like AOV render passes that are a vital instrument in lighting, finishing, compositing your VFX work, making it look complete. And how there's a sort of a simpler version of that happening in the color grading world, and we started to ask ourselves, how could they help each other? We wanted to form a picture where we had the best integrated finishing in our tool set in Flame. And the ML part really kicked in as we started to think, well, how could we do VFX at the speed of grading? And we used to joke with ourselves that if it were the other way around, that would be bad. So no offense to compositors out there, but bringing the speed and interactivity of color grading to the world of retouch effects, as well as relighting, applying effects as well as color through masks and rotoscoping. It was the kind of stuff we were starting to think about.
Yes,
and in this
Linda.
little video here, you can see some of the pieces that we've achieved. So what we have in Flame,
I see on my screen, I see Barry, I see Will,
oh,
I see
someone's speaking.
Oh,
Or maybe they go ahead and mute. All right, so this is a video of an artist working and using human body isolation, a machine learning function, as well as being able to use a depth generation, AOV creation, if you like, for live action content, which is done through a machine learning algorithm to build that Z-depth map for your shot, allow you to apply effects. We're looking at the advantage of having a face normals generator for a green screen shot footage. This happens as a machine learning render pass, if you like, that gets created, albeit for a live action plate. And then the advantages of being able to then relight that face, in somewhat extreme ways, if you want, or more subtle ways that you'd never be able to do if you just had a flat card with no understanding of normals. So like if this person were a 3D render, you would be able to render a normal pass. But in live action, we had to generate the equivalent. We also did some work here with UV map creation, so that the parts of layout of the human face that allowed us to generate mattes that you could then punch through both color and beauty shader type effects. So skin smoothing and other techniques. We also built a sort of a custom UV layout for that face to allow you to do custom eyebrows, nose, mouth, and so on. So where does the machine learning fit into this? Well, you can imagine that there's various sets of assets available. We took some different technologies to do both depth predictions through hundreds of thousands of assets, as well as semantic scene passing. So that's basically object recognition and being able to isolate an object, whether it's a human or a car or the sky or a body of water, perhaps. These are data sets that can be tapped into. Built our own proprietary algorithms, tensor network algorithms, basically to train the model. And then we also, for faces, we used a bunch of synthetic assets where we wanted to be able to get reference normal maps. So where do you get reference normal maps? CG renders standing in for live action faces, and we were very pleased to see that with that you're able to feed live action camera material and get the equivalent of a CG render pass as your output. So that's machine learning. Became very real for us, and we wanted to apply that research to these image processing and image segmentation historical problems, making mattes, making normals, and making extracting like the equivalent of an AOV. We like to call it an AIV from live action content. Here's a little bit of a timeline of what we've been up to since back in 2019. We first introduced the depth map and the face map, sky tools, human head and body extraction, the human face kind of part extraction, and then just not too long ago we introduced a salient tier. So salient as in the salient or most obvious object in an image or a region of interest. So check this out. This is a kind of a multi-purpose tool. We started to look at our ML tools a bit like keyers or trackers. You should have 3 or 4 in your toolbox And this one is able to recognize various objects in a scene. It's not based on pixel color. It's based on object detection. So a dark blue hand on a dark blue coat can be isolated because it's a hand. And then you could change the color of that, maybe use it to comp in if you need it. A blue car on a blue sky is a good test. So whether you want to isolate just that person, they're the salient object in that area, or the car with the person, and if you tweak the layout of what you're trying to see, you can actually exclude that person as they're no longer in the region of interest, for example. Get you maybe 80% there to pull off isolation for that shot. So these are cool things. In terms of the latest developments, what we've started to do is bring machine learning kind of into the DNA of new tools as we build them. And I expect that is what will continue to happen in our, in Flame as well as other tools, that we'll be thinking ML as we build new tools, what can be done traditionally versus what could be an ML stage, let's say, in a new tool. So recently we wanted to create a new camera tracker, camera solver inside Flame. And we looked at computer vision technology out there. If you've heard of SLAM, or as well as structure for motion, these are cool technologies that are kind of almost in an algorithm, not quite, there's more to it, but you can do things here that are pretty amazing in terms of solving space and knowing where the camera, in our case, is located. So we did that in our recent version of Flame from earlier this year. And this was the result, where you can actually see a high quality camera solve with thousands of points in just a couple of minutes, to be able to give you a place to do, place 3D objects for compositing, do projection, rebuilding of walls, buildings, heads in your scene. So another great tool in the kind of the power toolkit for a compositor. And the way that ML kind of folded into this was to do with natural object, what would you call it? Omission, or removing things that you didn't want in your camera solve. So in a camera solve, you want all the static pieces of a shot. You want the trees, the ground, the road sign, but you probably don't want to be tracking that moving car and that meaningless sky in terms of data. It's bad data for a camera solve. So that's something that we could naturally do. We actually daisy chained some of our algorithms to check for cars, people, sky, bodies of water, puddles. And you can see in the point cloud that what you have here then in the result, no car, no sky, and all the furniture or the static environment that you could then place objects into that scene that the camera would drive by is ready to go. So in summary, we've done this stuff so far. We've got some ideas for possible future areas to innovate with time warp, super resolution, up-resing, the idea of white balancing or color grade matching, as well as things that could be done with the human face and some more traditional uses of semantic recognition, like being able to identify a particular person or a person that should not be in the shot or should be in the shot, maybe for blurring out heads or for potentially isolating a known person in multiple shots. So that's what we're thinking about. If you'd like to know more, please look us up on YouTube on Flame How-Tos, as well as the future of work on Autodesk.com, where we're starting to see how this builds into our industry and others. And then there's some presentations from SIGGRAPH over the last couple of years that dive in a little bit deeper as well. All right, that's it from me, Barry. What do you think?
Oh my gosh, I'm gonna have to rewatch that because there was so much that you presented. Thank you so much, Will, for that great encapsulation of what's happening in Autodesk and Flame specifically. So now let's switch over to the Foundry. We have Mathieu from the Foundry. Mazerolle, I believe is how you pronounce it. I'm sorry for butchering your name. And if you could take over the presentation, and let's see the amazing stuff that the Foundry has for us today. So you're muted, Mathieu. You just have to unmute.
Great.
So
hi, everyone.
Thank you.
It's a pleasure to be able to talk to everyone today, and that was a really cool presentation from Autodesk. Similarly, I want to talk a little bit about the way machine learning fits into artist workflows. I think many of us here, regardless of what vendor we represent or what studio, we really feel the potential for machine learning to accelerate the creative process is really one of the things that we hope to unlock through this technology. Just to give a little bit of context, so I'm part of a special team inside of Foundry called the research team. And the research team is sort of something very special in the sense that we focus on really, really hard problems on time horizons that are kind of outside of like the usual product cycle. So that gives us the ability to focus on kind of long-term trends. And obviously machine learning is one that we've been working on for a while. We're broken into 3 teams inside of Foundry Research. We've got one team that's dedicated to cloud technology, another team that's focused on real time and more and more how that's affecting on-set and live workflows. And we have another team called the AIR team, which is focused on machine learning. If this presentation was a lot longer, I'd talk about all the great stuff we're doing in research, but I'll focus on the AIR team. The AIR team creates a series of tools mainly focused on Nuke, which is our compositing tool from Foundry. And we have a tool set inside of Nuke called the AIR tools. Those tools are made up of several things. Today, the first 3 in this list are available. So one thing we have is what I would call kind of stock machine learning tools. So these are sort of machine learning powered effects that do one thing and one thing really well. So examples of that is upresing. So there's a machine learning powered upresing tool. There's a machine learning powered deblurring tool, for example. And these are really great. They're sort of ready made, and you can sort of drop them into your compositing graph and work with them right away. But more and more, the way we kind of look at machine learning inside of Foundry is a little bit unique. We think machine learning really reaches its full potential when there's a maximum amount of artistic control over how machine learning is applied within the context of the creative intent. And for that reason, it's led us to develop Copycat and kind of an adjacent technology called the inference node. And I'll talk about those just now. And then I'll also talk about a future project we're working on, which comes from a collaboration with industry called Smart Roto. So I'll just get right into Copycat. Copycat is a really cool tool. So I'm going to speak over this video while it plays, and I might cut it off, but if you're interested, you can go to our Insights Hub, and we've got tons of stuff written about Copycat. Copycat is a machine learning tool that allows an artist to create their own machine learning powered effect. So essentially, as an artist, you can pick frames within your shot and feed Copycat before and afters. So you can take a frame, for example, in this case, we want to remove a bruise from an actor's face. So what you can do is you can go and take the face with the bruise, paint it out, take the same image without the bruise, and you can do that for 3 or 4 frames of your comp. And what will happen is Copycat will learn the relationship between those before and afters and create its own machine learning model that basically is how to remove bruises from faces that look like this type effect. And of course, the more you train it, you can retrain it and feed it more examples. and it gets smarter and smarter. And the really cool thing about copycat is then you can take that effect and you can reuse it. You can reuse it across other shots or across entire sequences, or you can continue to refine it and deploy it across your entire studio if you like. So this is a really powerful tool. And what's really great is you have a lot of control over it. Copycat has, no idea what kind of before and afters you're going to give it. We had examples of, puppets in a sequence where, the joints between the puppets were removed, and essentially there was a copycat model developed that figured out how to remove joints, in between pieces of puppets. So really cool type of tool that has a lot of potential. Here's another copycat example. This is the bruise removal actually in a short 9-second clip. So just sort of painting out those things. You just really only need to give it a couple of frames, and then copycat figures out how to automate the whole rest of the effect across the sequence. This is one of our Air Team developers actually, who made himself kind of a guinea pig for early copycat testing, where he removed his own facial hair. So that's kind of fun. But we took copycat even further. One of the things that we realized working with machine learning is, this is a really vibrant and active area where there's a huge amount of research from academia. Tons and tons of machine learning models are being developed that do all kinds of things like object classification or style transfer. A lot of these things aren't necessarily image to image type things like copycat does. So what we've done is we've created this new type of node called an inference node. What the inference node allows you to do is to take any machine learning model that you can get from anywhere from the internet, as long as it's a PyTorch model, and you can wrap it up inside of the copycat framework and expose it to artists. You can expose the parameters, and they can make use of that machine learning model from academia or within your own teams. So, for example, this is kind of a style modification machine learning model that I believe we got off of the internet and wrapped up inside of an inference node, and allows you to work with it directly inside of Nuke. So what's really great about this is, if you've got a special type of machine learning model that does something very specific, or you want to use something that does something very specific, well, you can now leverage the copycat framework to be able to bring that into your compositing software. Essentially, the potential for this is limitless. We really just have kind of scratched the surface with what the inference node would be able to do. So that's really cool. These things are available today. We think this is a really good start in terms of machine learning tools. There's even a before and afters article recently where one of the people on the Matrix project mentioned how they used copycat for one of the shots. It's really great, immediately useful tool that people are already putting to work. But we're looking to the future as well. And what we're really looking for is ways to even further accelerate and empower artists with machine learning. And one of the problems that we think could be most assisted by machine learning is roto. So roto is a very laborious and time-intensive process. And we feel there's just a huge amount of headroom to be able to go and bring machine learning to bear on the problem of creating really good rotos. So for the last few years, we've been working on a project called Smart Roto, and this has been a collaboration with the University of Bath and DNEG. And what we're planning to do in the next, now that project is wrapping up, we're looking to continue working on that and evolving Smart Roto into something that we can bring out into the wild so people can put it to work. Roto is a really hard problem. We figure if Smart Roto is something that can just essentially cut off a big chunk of the the manual work associated with getting good roto and just kind of get people a jump start, it's already a really big win. So these are some early examples of our Smart Roto work, and essentially having the machine learning system figure out how to build intermediate keyframes for rotos or assist with creating the roto shapes. And we're hoping to be able to handle even more complex examples. One of the things that we think is really powerful with machine learning, and this is comes from my colleague who's the head of our research department, Dan Ring. One way we think about it is, in the early days with content creation tools, there was the ability to have SDKs. You could go and create a C++ extension to a content creation tool in the 90s. Then we moved to like great scripting languages and plugins. We feel where the direction machine learning is going is, this is the next generation of extensibility for creative tools. We think people will be building machine learning tool sets and entire workflows that essentially is the next level beyond, scripts and plugins that we see today, which are essentially, standard programs. We think machine learning itself are going to be like little mini brains that you can use just the same way you use plugins today and be able to deploy them across organizations or across projects. So if you want to learn more, our Insight Hubs on Foundry.com is a great place. We have all sorts of thought leadership articles. We write about the stuff, talk about it, and we'd be happy to hear from you and hear more about how machine learning is being put to work. So that's it. Thanks very much.
Thank you very much, Matthew. Anything you can do to speed up Roto is a godsend. So thank you so much for that. I'm happy to see the work that the Foundry is doing in this regard, and it's very exciting time, as I said, in this arena. So next, we're going to go to Ryan Laney, who actually employed machine learning, and welcome to Chechnya. And he's done a lot of he's an award-winning, it was the HPA award, actually, again, Linda, that I ran into him there, and I just begged him to be part of this panel. So I'm very grateful that he's here and with us. And Ryan, if you want to go ahead and take it away.
Before Ryan goes, Barry and Ryan and all the panelists, just see if your cameras are working, because we'd love to see everybody. That's it. Go ahead, Ryan. Sorry. Great. Go, Ryan.
Okay, Ryan. Let's see. He was on before, and I was emailing with him.
He says that his camera won't turn on. It's blocked by host. I'm here, but no control to share.
Oh, yeah. Did we not make Ryan a presenter?
I'm sure he did, but we might have to do it again. So I take it Rafik is on it as we're speaking.
Okay, well, let's just stand by for just a minute to get Ryan on, and if we can't, we might just go ahead and pivot to Brian and Victor and have him. Okay, yeah, Ryan just posted that we should go ahead and move on then, and while we sort out the technical issues. So sorry, Brian and Victor, to put you on the spot, but I think you're ready. You were ready from the rehearsal from yesterday. So go ahead and take away, Brian, from Unity.
Thanks, Barry. Great presentation so far by everybody. Really exciting stuff. Today, I'm joined with Victor Kam, and we're going to talk about AI-assisted artistry driven by machine learning in regards to an example-based workflow. So what's an example-based workflow? In context to say ArtEngine, which is a product we're going to demonstrate, you would start with seed data. Now that could be photometry or photogrammetry scan data, could just be an image coming off your phone, and you would bring it in and apply a human intent. That intent might be to take that image and remove any seams and tile it to an 8K PBR material and export it as an OpenEXR into Flame to use as a texture. And then we apply automation to it, which would then take the AI component, which would either enhance or expand or transmute that image and provide you a feedback. And through that feedback loop is where the machine learning takes place. So you can tweak it with the human intent and go through this feedback loop. And this is where we developed and call this process the example-based workflow. But we didn't really invent the example-based workflow. The industry has been using it for some time. We've just been calling it the photogrammetry-based workflow. But to use that same example, the seed data in this case would be all your photos that you took of this 3D object. So you went around and took 100 photos, and you then put the intent in there as you want to turn that into a 3D model, and then the software automates that process. So the beauty of using machine learning and AI-assisted artistry, as we saw in the earlier demos with Flame and Nuke, is just how it assists the artistry process and moves the creative forward. Where procedurally, you can think of it as the exact opposite of machine learning, right? With procedural artistry, the algorithms guide the data. And then in the case of machine learning, it's the opposite. Data guides the algorithm. So if you were to think of this in terms of game programming and AI in a video game, the procedural approach would be to create and code a bunch of statements and equations to tell your player exactly how you want it to act, versus a machine learning process would be, on the other hand, you actually just simply play against your enemy agent, and in the process, it learns and improves in that experience. So you can do that with software as well. So procedural artistry is also a mathematical representation of what an object should look like, but you use tools that have these algorithms that guide the data, and to start from scratch and to create, a photorealistic image can get quite complex. So as an example, let's take something like seam removal and creating a PBR material. If I were to do this procedurally, you start by wrapping the image around, the entire axis of the X and Y axis by 50%, and you wind up with this harsh seam. But you can take that original image and use the shift and shape process to, cut a plus sign cross section out of it and merge it in with the original. So you wind up removing that seam in the process, but you need to do that across all your PBR maps, and it's quite manually intensive. And you can see, you can wind up with ghosting images and problems. You can correct for that with, graph cutting tricks and all the other steps and round tripping through softwares. But this is where the time consuming process comes in, when you can really automate that using machine learning. And really what's happening is that with machine learning, you're learning through the experience beyond just the direct programming. It's kind of like statistics in nature, but different. And we're not really just inferring information from a data set any longer. It's not just the metadata about it and plugging that in and having the algorithm guide the data. Now it's the opposite way around. We can use the data and use the machine learning to train on it and generalize and create unseen data that the AI can make educated predictions on. So we're going to talk to a tool today in ArtEngine and give you a practical demo, but Unity actually has multiple teams working on applications with machine learning. In relation to our talk today with the Visual Effects Society and working in context of VFX, we just brought a new member onto the team with Ziva Dynamics, and they're incredible characters. They're humans and they're animals and so on. That whole face process is actually, again, trained and learned on through machine learning. That's really what optimizes and provides the great feedback results. So let me just play down a short reel of some example tools that we have inside of ArtEngine that benefit from machine learning and AI. One second. Do the old screen share check. Okay, let's go back to that. Can you hear the audio now? So you're doing AI-based seam removal across multiple PBR maps automatically, so you don't have to go through that time-consuming process. Or do things like material extraction, take a picture of something and then select it with AI data and then extract a new material. Or using tools like content-aware fill, but having it work across all the maps simultaneously. Very fast and lets you move forward. Or using tools like a clone stamp tool, but painting, say, on your normal map and having it update on the albedo at the same time. We talked about AI-assisted rotoscoping, but creating mats is difficult. But if you can give it some guide data and create super pixels and just pull mats automatically, very powerful. Color correction as well, creating color palettes and automatically generating maps from your sample data, or using tools like style transfer, pushing the intent of one image into another. These are all driven by AI and machine learning, including tools like upres, very powerful tools to do 2 times and 4 times upres. So with that, what I want to talk about today is what we're doing with creating tileable materials from just a single image. So on the left-hand side of the screen here, you can see there's just these 4 images that were downloaded from Google Images and turned into tileable materials and for 3D. And in this case, we can also take, say, an original image and use AI to generate like a delit albedo map or a normal map and height map and roughness and ambient inclusion, or even a glossiness map if applicable. And then seamlessly tile those across all the maps. It's automated. In fact, it took me way longer to create this animation in PowerPoint than it would be to take a photo, bring it into ArtEngine and ask it to remove the seam and tile that material. Cleanup on photogrammetry scans is really powerful. If you take that, point cloud data and bring it to something like reality capture, it'll generate, this material, but then you'll see that there's holes missing in it. There's some data that just, wasn't able to, replicate. And so you can use a mass paint node and seam removal to actually organically fill in that data with AI. And using, a matte node, just combining 8 and 16 images, using a photometric stereo rig is pretty straightforward, but adding data to guide the algorithm, like the lens focal length and the distance to the object and the light angle azimuth, really create a high quality PBR material. This is a good one for visual effects and virtual art, but there's been this Barty capture method where you could use a chrome ball to, capture light angles from different images and then combine those with a matte node. But it's really been more of a command line tool. We've actually put a UI around that with the chrome ball node and our matte node to really allow you to create high quality PBR, albedo, and normal maps. Quite often, in serial visual effects shows, you have content you need to repurpose or you want to reutilize, or you're doing visual effects now at 4K instead of 2K. In this case, let's say you had a Quixel Megascan image here and it's kind of cool, but your art director says, I need you to remove that gash and take out that, silver screw in there. And you can, go in there and paint that out in Photoshop, or you could use a content aware fill, generate all the other maps, and also mutate it into several variations. The mutation node is very powerful. You can take, an asset in your library and mutate it and use like color match tools to create endless variants of an image. And that's great when you're sort of creating environments and biomes. We do a lot of color correction in Hollywood, and auto detecting a color palette instead of just sampling a color that might have that same wavelength and other portions of the colors in the image, and then trying to clean up the mats to pull a proper key can be done automatically with AI, where it'll auto detect that and you can then remap the colors. JPEG compression removal isn't exactly AI driven, but combining that with machine learned and trained upres tools for 2x and 4x upres can really make for quality results in that remastering process and retooling images for visual effect shots. And before I hand it off for demo, I wanted to talk about one more other AI tool that we have in beta development called Style Transfer, where you can take one image and apply that intent into another image. We all know the Van Gogh Starry, Starry Night image, and I'm sure you've all seen this background 100 times over the last 2 years on Zoom calls. But if I were to take that image and combine it with this image, I could come up with like Starry, Starry San Francisco. So in this example, for concept art design, quick, iterations of how you can maybe paint something or take it down a direction, or background, artwork, and animations. This is a tool that we're in development on that's, I think, going to be very powerful. And with that, I wanted to hand it off and let Victor take us through some practical demos of these AI tools and how they're utilized and how simplified it can get using AI-assisted artistry over procedural artistry.
All right, thank you so much, Brian. Yes, I'm just going to quickly jump into the tool and just show some of the results of what Brian was talking about. So this is inside of ArtEngine. I have a few pre-computed graphs already just to show you basically, the cool tools in action, really. So my background is a materials and texture artist. So one of the first things that you'll find that if you're capturing real world data is the first thing you need to do is obviously remove the seams, as Brian mentioned, right? So using something called texture synthesis, we can quickly remove the seams with just a simple click like that, right? And what this will do essentially is around the border edges is identify neighboring pixels and then rearrange itself into, again, neighboring pixels that fit with itself, thus essentially removing the seam like this, right? And we're constantly improving the synthesis technology. We do have a new version fairly coming soon, which is going to imply a lot more ML training data to that to just improve some of the quality to that. So with this seam removal here, we also have something called mutation, which is like a kind of like an Uber seam removal tool. And what that will allow you to do as an artist, especially in the VFX or texture artist industry, is not only remove the seams, but also square off the image. If you need to square it off for, if you're working in game production, you want to use powers of 2, but you can also, if you kind of scroll down here and take a look, we also have something called world scale. So we also implemented world scale with texture synthesis. This is to maintain texel density. If you're working on an environment type of production where you have to maintain texel density with all your textures. And this is also going to allow you to create different variations with it. So what this is actually doing, this algorithm is doing, it's synthesizing new data essentially based off of the parameters that you placed in here. So this is really, really a good way to, again, just take raw images and just create them into tileable sheets to whatever texture resolution that you'd want. So I'm working on a single image right now, but we all know working with materials and shaders, you need the other maps with it, like the normal maps, roughness maps, and so forth. So this does work, of course, across a full material stack like this. So I have a normal map, a height map, ambient inclusion, and just a color map. So this is actually processed photogrammetry data that I've baked onto a flat surface, a plane, basically. And one of the problems that can come up with using photogrammetry is you don't have all the captured data ready to go over here. So what you can do now is you can actually guide the algorithm like this with a paint node. So I just painted this in a black and white area, and I'm going to use the texture synthesis again to essentially synthesize new data in those areas that I need it to be. And so right across now that we have a full PBR stack now that I can use for my production from my photogrammetry data. So this is where a lot of the photogrammetry people have kind of come to this tool, because when they do their scans, they usually end up with something like this, and they want to fill in that stuff, and they will use the seam removal tool with one of these guide masks to fill in that area. So these are some of the cool things that are currently in our product. We're constantly updating these synthesis technologies. The next thing I'm going to show you real quick is what we're currently training with machine learning right now. And what we're doing right now is taking single images like this from your phone or texture library. And usually what happens is if you have an image like this, you want to build a full material out of it. The old school kind of method is using the shape from shading technology to generate the height map and the normal map. As we all know, there's lots of artistic control that you need to kind of adjust to make it accurate. And it usually looks a bit too pillowy like this, right? So what we've done is we've gone ahead and actually gone out into the wild, captured thousands and thousands of photogrammetry of surfaces, and we're actually using that as our training data now. And what we do is we take that photogrammetry data and we synthesize lighting directions on it to simulate a normal photo that a normal person would take from their phone or their camera. And we train the network in that regard to kind of learn how the height data is actually interpreted through those lighting conditions. And what you'll end up is with a really, really accurate normal map from your single image, as opposed to kind of going from the old school shape and shading algorithm like this, which is a lot of artistic control, a little bit too pillowy looking, but this is actually trained on accurate data, right? So this is a really exciting thing that as a texture artist, I would love to use because I hate doing photogrammetry all the time. It takes a little too long to do. So with that said, we're currently training and using ML to do single image to height data. We're also training our data set to, again, with photogrammetry data, I'm working with a 1K map over here. So if you have an old material library with a lot of older textures that need to be up-resed, we're also using that training set, the same training set to actually up-res these things, right, as well. So this is a 4 times up-res, and we're still training this, so the results aren't completely there yet. But if you kind of see the before and after, you can see kind of how crispy that gets over here. Now, we all know that there's a lot of up-resers already out there, like the NVIDIA up-reser, Topaz Gigapixel, as well as one popular up-reser. One thing that we're doing currently that's a bit different than other people is we're actually training our set with normal maps. And you'll notice if you run normal maps on other software, they don't up-res as well as they potentially could. So we do have normal map upreser as well to kind of keep that fidelity. Again, this is a 4x upres on normal map. So these are some of the cool things as myself as an artist that I really love to use with these tools, and just like how useful it can be, kind of coming from a procedural workflow and actually using some of these awesome ML-based synthesis technologies for material creation. Yeah, so that's what I wanted to show you guys today. So I hope this kind of whets your guys' appetites for the artists for materials, and I'll pass it back to you, Brian.
Well, that was fantastic, Victor. Brian, do you have a closing word for us?
Yeah, Brian, you're muted, I think.
It's only 2022. I haven't learned how to use the mute button. It's you know, a really powerful tool with lots of machine learning. We just gave you a sort of little visible approach to some of those tools. But if you want to learn more and really dig into machine learning, we have a whole blog on it at unity.com under a topic called machine learning. And then Unity ArtEngine, you're welcome to try out a free trial or test it out or learn more. But it's a powerful tool, really with a lot of AI assisted artistry. And then we talked a lot about photogrammetry and capture, and if you need to learn more about what that is or get ready for it, we also have a nice white paper on create.unity.com called Get Ready for Photogrammetry that you could take a look at. And if anybody needs more information on that, feel free to email us directly. But thank you, and I'll pass it back to you, Barry.
Thank you so much, Brian. That was amazing. I'm speechless after watching all of these presentations, and I hope that the next presenter you'll enjoy as much as I have watching how these tools are used in real programs and real projects that are been well recognized by the industry. So without further ado, let's switch over to Ryan, and we'll close out today's session with seeing machine learning in action in Welcome to Chechnya. Ryan, go ahead and take it away.
Hi. Seems to have another problem screen sharing, so I apologize. My name is Ryan Laney. I will try to sort it out while we start this. And looks like it wants me to reboot Zoom, permissions related. I'm terribly sorry. If you guys can give me 30 seconds, I'll be right back.
Okay. Yeah, why don't you go ahead and do that, and we'll go ahead and there's Alan's raised his hand. So Alan, do you have a question in the meantime while we're waiting?
Barry, I don't think Alan is a panelist, so he's muted and can't talk. He'd have to just send his question. Maybe there's a question or two that's up on the chat that can be on the Q&A that can be answered while Ryan is preparing.
Okay, yeah, that's a great idea, Linda. Let's go ahead and let's see. Okay, it looks like Will's been answering the questions in the chat as we've been going.
Oh, that's wonderful. Did he answer the question from Annie Chang? I was thrilled to see her on.
Yes.
Will, wonderful. And thank you, Annie. It's always wonderful to see you. And oh, great. I'm glad these questions are being answered right away for people. That's great.
Yeah, thanks guys for doing that.
Alan, do you want to type your question?
And Mari, there's a raised hand as well. So go ahead and type your questions into the question box.
So are all the questions answered, Barry?
It looks that way. Let's just give Ryan another second.
Sure.
To jump on. Oh, looks like sure. I see a screen there.
I do too.
Yeah, Ryan, you're back.
Hopefully.
Fantastic, fantastic.
Definitely, I see your screen. So yeah.
Okay, I'm closing out.
unable to start video, so I will do this with a thumbnail. And as long as you can see the presentation, then we're good.
Yeah, I can see the full screen splash screen that you have. So thank you for getting that ready.
Fantastic. So my name's Ryan Laney. As I said, Teus Media. We produce an automated face replacement technique that uses machine learning. And I gotta say, I'm like a kid in a candy store right now because the other 3 presentations were just amazing with the tools and the thoughtfulness of the tools that are coming out, and how those are seem to be really engineered towards producing a better result with the same amount of effort. And we did this this project in the same sort of idea of like how do we produce a better result with a small amount of effort. I have a background in visual effects. I've been producing films, effects for feature films since the mid-90s. And a few years ago, I got involved with documentary film production, helping documentary directors protect identities of their contributors. I'm going to use this time to talk about the project where we developed this automated face-to-face replacement technique. And I'll talk a little specifics about the machine learning tools, which I haven't really gotten to do in other places because this is a more technical group. So that's great. In the end of the project, we were able to produce over 400 shots on pretty much a shoestring budget. Documentary film do not have the budgets of large productions. And so everything we did needed to be streamlined, and machine learning helped us create a pretty reasonable result for almost nothing. It can't be understated that the work relies on, this 25, 30 years of experience in visual effects and some really fantastic experience with wonderful teams at ILM and Sony and DD. Without all that ground knowledge of, how to pipeline work, this wouldn't have been possible regardless of the benefit of machine learning. So the machine learning is a really fantastic tool. And I think I saw in all the other presentation that these are really helping professionals produce better work.
Yeah, there you are. Ryan, I was just going to answer a question. And so you have, sure. You have images to display because there was just a blue screen for a little while. So please continue.
I'm sorry. I was one behind.
Yeah, no worries. No worries. Yeah. No worries.
So let's see. So the case study that we're going to talk about is Welcome to Chechnya. It's a documentary that chronicles the persecution of LGBTQ youth in the Russian state of Chechnya. It's a really terrible human rights situation, and the director, well, as most visual effects projects, this one started with some challenging constraints. The budget is one that we talked about. But these were compounded by security concerns about the safety of the contributors, and the director, David France, needed it to be able to tell his story with contributors that couldn't be seen on film. So a lot of constraints. The traditional way to do this is through blurry ovals or silhouette shots where contributors are placed into shadows. In this case, David was concerned that these traditional methods would disconnect the audience from the film's contributors, and so we came up with this technique to automate the face replacement and give the audience somebody to look at. So the film was shot with hidden cameras and cell phones, and in situations that would have been too hard to control the lighting for the silhouette shots. And as we saw, like the blurry ovals disconnect from the audience too much. And David was really concerned about maintaining the connection between the audience and the subjects. This particular group of people are already sort of vilified in many places in the world. And so it was of the utmost importance to tell a human story and not abstract these people into figments. When David first came to us, he was interested in the idea of applying some sort of cartoon effect. This would be something like a scanner darkly or rotoscope and things that apply. They had done tests with artists drawing over the frames, but that left some room for interpretation of the emotions by the artist. They also tried, again, this cartoon filter, which created caricatures of the contributors and didn't do much to hide their identities. To get around this, they tried warping the faces. And this ended up actually creating some kind of grotesque looking characters. So fast forward through a year and many attempts, they couldn't get it to work for several stylistic reasons. But Johnny Hahn, a colleague of David's, who introduced us to the project, had suggested the idea of using a style transfer, which we've heard about already, and machine learning is really kind of the key mechanism of this, of understanding and being able to decouple the style of an image from its content. So in this example, you can see that the style of this painter is applied to actually a different painter. Usually it's a photograph or some footage. So around this time, I came across a couple of papers that influenced our step forward in this. Deep image analogy, which uses a VGG19 network, which is this classic hourglass shape. And another on the idea of semantic style transfer, which would allow us to sort of improve our results by understanding what is going on in the image rather than just trying to generically map gradients and line weights. So we did this test where we applied painterly style, and instead of using a cartoon effect, we used style transfer. And we very quickly realized that style transfer had some similar issues to the cartoon filter application, in that even with a lot of pixel changes, it did very little to hide the person's identity. In fact, if the goal of style transfer network is to retain certain qualities of the picture, it also happens to reveal the identity. So when working well, style transfer is terrible for identity protection. What we actually want to do is change the style of the face or the style of the features that reveal a person's identity, and not necessarily the style of the overall image. I was inspired by this image from 2012, which was out of the University of Glasgow, a face research lab. And the more subtle idea that we might be able to create this transfer function from one to the other, from any face to any other face. And around the same time, also, like, this combination of research all at once was this a lot of work into eigenfaces. We thought if we could treat instead of, a lot of these eigenfaces and face data set things, they're created on multiple persons, like many thousands of people, and they give you a few images of each one. And we thought, well, if we could use many faces of a particular person, we could understand what was going on in the content of that person's face, what their expressions were doing, and maintain their expressions while changing their styles. So in a sense, we're creating a network where we're treating eyebrows or eye shapes or lip shapes like brushstrokes. So principal component analysis is a key component to how we got there. And we knew in order to create this transfer of styles between two different faces, we would actually need this data set. And I really appreciate all the work of all the tools, all the other tools that go into, like, how do you create and how do you manage this data that is required for any machine learning process. So with the painterly example in a photograph, you've got tens of or hundreds of thousands of brush strokes where you can understand gradients and lines. And with a photograph of a face, you only have, 2 eyebrows per picture. So we need a lot more photographs to be able to represent all the things that were possible. So we shot a test with, this is Abraham Luna. He's an actor out of Los Angeles. And he ran through some basic motions. We had him say some phonetic pangrams, which cover lip shapes for the English language. and we had them going through. We actually shot with an small array of cameras, which got our face angles. So now we have frames of the footage of the original contributor and similarly lit frames of our face double, and we need to create a network to find a good transfer function between them. So given our on the left, our contributor, and I just want to, I'll put a footnote in this particular contributor whose face we did cover is now known to the world. So we're not revealing anybody's identity here that isn't already known. So in most things, you'll see this very simplistic hourglass shape where there's an encoder on the left and a decoder on the right, and you encode to this representation in the middle. It doesn't quite capture what we're actually doing. This is also a very simplistic view, but with one extra level deeper. So this is this is not actually VGD19, but it's a similar representation where you've got larger sized images or spatially larger images on the outsides, and you've got spatially smaller but deeper images on the inside. And so this small, which is kind of a little thumbnail in a lot of pictures, in the middle is actually a very deep, you could say, hash table for this compressed representation of what the face is doing in the middle. The net effect of this middle hash table is where we represent that principal components of the incoming data sets. And the outer layers are mirrored, so they represent increasingly smaller details. So as you, the core motion is on the inside and the details are on the outside. So again, our largest variations in the image, this might be view direction, lighting changes for a particular person. And then on the outside, we have the smaller things. So facial expressions are also going to fall into that center area. Said differently, in the center we have, so this green area, we have what is the eyebrow doing, or what are the lips doing, raised or lowered, and then on the outside we have increasing refinement of what that specific eyebrow looks like. Going back to style transfer again, we can say that these things in the red area are things that we want to change, and these things in the green area are things that we want to keep. Just of those sort of components that we want to keep, these are view direction, lighting angles, and facial expressions. This is sort of a visual of in a particular shot from the film what we're talking about. And this actually, just for fun, is actually one of our transfers for this film. Again, this is not original footage on the top. This is already a transfer, so we're not revealing anyone's identity here. So how do we pair these two face sets? Again, we're running the same network on two different face sets. And on the outside, we have the detail, and those are naturally independent. So we keep those separate. But as we get closer to the common features in the middle, we pair these layers with the loss function, so that as we run and learn the network, the center most compressed representation of the network is either very close or similar for both sets. This allows us to use this common representation for both sets, so that that is actually what allows us to swap our encoder and decoder at the end. There's a lot of pipeline around what we're doing, and I want to stress again that machine learning is not a sort of big single button that just swaps faces. This is the machine learning portion of an also very simplified view of what we're doing with their images. We also use machine learning models in these other places in our pipeline. We approach this as a visual effects tool. So as we're learning and building our own models and finding new ways to do things, we're implementing those as sort of a general computing practice within our pipeline. So one of the things that we do is we use a model to identify faces. It's a great way to say, what does a face look like? Here's a face. We also, when we have in a case like this where we have multiple people in a scene, we use a facial encoding to identify, so we can keep all the frames for each person separate and tracked separately. We also use models for segmentation, which you've seen in other tools. I'm just fantastic that these tools are in the artist, available in the artist tools now, and no longer command line. But we have segmentation models to help us remove things, and then we used video in-painting algorithm to in-paint fill back in, so we can get a whole face again. So jumping back to what we're doing, the first face replacement was in 1993. Obviously a long time ago, but the core of face replacement is you get two people to do the same thing, and then you're able to easily swap them because they have the same lighting and the same action. Moving forward, sorry, just to credit, this was ILM and I didn't work on this particular project. I didn't work on this one either, but this is another ILM project where, obviously you have an actor's motion is driving a CG version of their face. And we wanted to build our pipeline off of something similar. So, so to do that, we wanted to pair the data that we have of both sets of people. The reason why that's important is that these machine learning models has a very small amount of memory that's available, and we want to really maximize the use of that, the memory in the GPU. And if we're using a lot of these models they use generalized representations of a whole face data set, and then they try to learn it in a generalized way so that any face comes in, you can create a new face coming out. But that's not really what we're after in visual effects. We're really shot specific. And so to look at it from that picture earlier of face angle and lighting and expression, we generally, for a shot, we have a very limited set of that. If we were to use a generalized model, we would have a very small, we would be using a very small set of images, a very small amount of the available memory. So with our face data sets, we've got the subject and the double, and by pairing the face angles and the lightings and the expressions, we're able to maximize that center memory. Also, we swap backgrounds. We do a pre-composite where we composite the foreground actor over the background from the plate, so that we're further with all the pixels that are being seen. We also apply some mats for segmentation to really make the best use of this memory in the middle.
Ryan,
yeah.
I'm going to jump in for a second,
Mm-hmm.
and I'll just give you a 3-minute warning. We have to end the presentation at 1:30, and I do want to allow some time for questions.
Mm-hmm.
We're getting some questions that are coming through from the VES that are not on the Zoom, so I'd like to have some time to answer them as well. So just go ahead until 1:15, and then we'll open it up for questions. Thank you so much, and sorry that it just worked out technically this way with a little bit of a late start, but we do need to begin.
Yeah, that's fine. That's fine. There's actually I'm pretty much done. The last footnote is that in this data preparation, we get to do some fun things. This was really just a fun thing where we de-aged our data before pushing in, so that we could have an adult face swap onto a child. We did this, we've done this a couple of times now. And so really this is just a footnote, this idea that in the machine learning process, data is really important, and that raw data is not necessarily like the best thing. You can do a lot with that data before you come into the machine learning process, and really to maximize that model and to maximize what you're doing with the model, the smallest amount of important data has really, for us, worked out the best. So I'm Ryan, Teus Media. We use TensorFlow, NumPy, OpenCV. So those are like Python is our backbone, and so really like we don't have a lot of like information out there, but TensorFlow and Python are really great resources for learning more about this, and that's all I have.
Well, that's fantastic. Thank you, Ryan.
Sorry, I know I ran a little over. So
no, it's fine. We had a little bit of a hiccup at the start, just getting the streams merged between the different organizations. So I'm just going to, a lot of questions have been answered in the chat, but Ben from the VES has been feeding some questions to me via email. So I think I'll just go ahead and start with a question for Mathieu from the Foundry. Dmitry Korolov asks, do you have any time frame for implementing Smart Roto into Nuke?
Yeah, thanks for the question. Roto is a hard problem, and I think giving a time frame for when it can be solved in a usable way is an even harder question. I'd say probably not soon, but probably closer than we hope. But definitely something we're working on over the span of the next year or two.
Okay, thank you for that. It's another question for all the panelists. Machine learning research has become faster than any production of VFX software by any company. What needs to be done from your point of view to make new research available faster in the visual effects industry? That's a great question. So that's open to anyone who'd like to answer that. Any of the panelists, please.
Well, I would just say I was pretty impressed by what I saw today, integrated into some of the commercial leading applications out there. And I know at Unity we have quite a bit more, and we could probably have 2 or 3 sessions, alone just on this subject. But I feel that having a conversation with SMPTE and VES is the first start, to kind of educate this stuff. And I think we'll take it back on the SMPTE Hollywood side to think about, more presentations along this line over the next year to educate people. SMPTE, along with CGRAPH and NEB, hopefully we get some networking events going again in 2022 where we could get in front and demo more of the stuff. But definitely check back. I think there's a lot in development right now in support of visual effects.
Thank you, Brian. And another really good question from the VES. So I think something like this will be used to mimic mouth movements for watching, for dubbing foreign movies, so it is easier to watch. Someday maybe even modulate an actor's voice into other languages and change mouth movements for whatever language you want to watch, so as to keep the same voice. This is really interesting, and I know that Disney puts a lot of effort into making the different singers and the different languages sound alike, but this is a whole nother level of localization. Localization is a huge part of what's happening in Hollywood, of course. So is there anybody who has some insight into that about how it could be used in local machine learning, being used in localization?
I think there's a company that's doing it for not for films specifically, because that's a very it's a very hard problem to get all the available angles, but they are doing it for commercials, and they're able to produce, I believe, 40 different languages. And there was a football star, a soccer star that did an ad recently, and I think they pushed it into something like 30 or 40 languages.
That's really interesting. I had no idea.
Synthesia, I think, might be the link. I might have that wrong.
Yeah. If you
really fantastic work.
If you want to post that, if you could find that and post it into the chat,
we'll do.
Ryan, that would be cool. Let's just do one last question from the chat, and this is another really good and very timely question. Are there watermarks, from John, are there watermarks left to be able to see if what we're seeing is a deep fake? That's a really interesting and very timely question. So that's open for any of the panelists.
And panelists, please feel free to put your videos on so we can see you, like we see the handsome Brian.
I can take that. We've had a lot of conversations about the ethical uses of the media, and we include a tell, what we call a tell, which is a soft edge, so that if you were to, you don't even have to look for a watermark. We make it visible so that we're having this honest conversation with the audience. And Adobe is working on some really interesting sort of like chain of history for images that might be incorporated to be able for people to tell. If somebody wants to, fake something, they're going to fake it. But for those of us that are above board, there are ways that we can show things.
That's a really interesting and I love that answer, Ryan. I mean, it's depends on your outlook or ethical outlook on these things. So that's great. So I'm just inspired and awestruck by everything that we've seen today, and I'm really glad that everybody was able to participate in this panel. I'd like to thank the panelists. I'd like to thank Hollywood SMPTE, the Visual Effects Society, and all of our viewers, and this will be on YouTube, recorded and placed on YouTube, and also available through the Visual Effects Society as well, through Facebook, I believe. Yeah, Linda, let's just wrap it out.
I just want to thank everybody and let you know that our next meeting is going to be very quick to come. It's going to be, I believe, on February 16th on cybersecurity. Just save the date. We're still working on it time. But Mark Zorn, Deborah Kaufman, and Juan Reyes are involved in this, and it should be really exciting. Again, thank you, the panelists. It was wonderful. Rafiq, I know you had quite a challenge ahead of you here, so thank you for everything. We really appreciate that. And I just hope everyone has a wonderful day. So I say we sign off, and I hope you all have a great week. Thank you.
Thank you.
Thanks, everyone.